So this is developed by Dennis Ritchie. He is the father of C language. So he developed it in the year 1972. So there are many, and remember, C programming or C language is not the first programming language. So before that, there are many programming languages exist, and from the drawbacks of those programming languages, but those languages are also having some good concepts. So by taking the concept from those languages, like Algol is algorithmic language. So from those different programming languages, the good concepts of them are taken, and by adding few concepts, so this C programming or C language is developed by this Dennis Ritchie in the year 1972. Okay, so the reason why he started, he faced troubles with these languages is, so when he is doing his PhD course, so when he is writing some program, so he faced some difficulties in this with these languages, and he thought of why not to develop a language which can overcome these difficulties in these languages, and then he started developing this C language. So after 1972, when he released it in 1989, ANSI. So this is American Nations Standard Institute. So it adopted it, and it began the definition of standard C, and that means so these are the basic things that should be included. That was defined in the year 1989, and later that is taken over by ISO, International Standards Organization, in the year 1990, and the version is named as C89. Well, this is the basic history of C language. So getting into the concepts. So first we'll discuss with identifiers. So this is the very basic unit or basic word you write in C in programming language. So that we call it as an identifier. So identifier, what is an identifier means? Identifiers are simply the names that you give to the data and other objects in the program. When the user is willing to give some name to the data. So previously we told when we are discussing about algorithm, I told you. So take two numbers as A and B. Right. Take a number as number. Take a value. So there we are considering them as A and B. Sometimes in some cases you will take it like when you are considering the data of a student. If there is a program, so there you are taking the data of a student. Excuse me. In that case, you will take name, you will take roll number, you will take his branch, his year, his college, his marks. So the names that you use for that data, those names are called as identifiers. When you are considering an employee, details of an employee, you will say employee name, employee ID, employee designation, employee salary. These are the names you give to the data. Employee name, he'll have some name, but that is represented with employee name. Employee ID, it may be 1, 2, 3, 4, 5, but that ID is represented with employee ID. With this, under this name, employee ID, you'll represent that number. So these names are called as identifiers. The names that you use for storing your data, and some other things like we'll come across with arrays. We'll come across with function names. So in all these places in structures, so we'll use some names of the structures. So in all these places, we'll give some names. Those names are called as identifiers. So when you are writing an identifier or giving a name to the data or to that object, you have to follow some rules. For giving the names, you have to follow some rules of identifiers. So what are the rules for writing an identifier is, first, you have to use only alphabets. So capital A to Z, or you can use small a to Z. Lowercase and uppercase alphabets are allowed. And second, you can use digits from 0 to 9. And no special character is allowed. No special character is allowed except underscore. Except underscore. So only these are allowed. That means alphabets from A to Z, lowercase and uppercase, digits 0 to 9, and only special character that is allowed is underscore. Special characters means the symbols that you can see on your keyboard. You have hash, you have dollar, you have percentile, and at the rate. These are the special characters. Or else you can say plus is equal to. There are also special characters, less than, greater than. So no other symbol is allowed except underscore. Okay. And no white spaces. The name of the identifier should be only one word. It should look only like one word. But sometimes you may have, in one identifier, you may have multiple words. But those multiple words, even you have multiple words, it should not contain a white space. It should not contain any white space. What you want to do, you can do when you have uh, a name of the identifier with multiple words inside it. You can write like this: student name. You have to combine them, but you can separate them by using this lowercase and uppercase alphabets. Or else you can write like this: student name. So this is the main purpose of using the underscore. This is the main purpose. So when you want to separate the words, they looks like separated, but they are combined. No white space should be allowed in the writing the name in the identifier. And the important thing is, out of alphabets, digits, and underscore, the name of the identifier should not start with a digit. And you make sure the name of the identifier, it should not start with a digit. You can say student 1, student 1, student 2, student 3. You can write like that. But you can't write like this. This is not allowed. This one is not allowed. It should not start with a number. Identifier names, it can start with underscore, it can start with lowercase or uppercase alphabet, but it should not start with a digit. Okay. So when you come across writing a program using them, then there I will tell you, okay, this is identifier. So here we follow the rules. So I'll say it there. So before that, you should know what is identifier and how to write them. These are the basics. Okay. And next, other than identifier, so we have one more set of words. They are called as keywords. They are called keywords or reserved words. They are called as keywords or reserved words. So what is this keyword or reserved word? So keywords or reserved words means the words which are having specific meaning or a special meaning in this language. As per this language, these words are having some special meaning. So, for that special meaning, these words are reserved in the language. These words are already reserved in the language. So, when you write any name of the identifier, any identifier name you are writing, that identifier name, it should not include these keywords. The identifier name, it should not be same as your keyword. So we have 32 such kind of keywords are there. We have 32 keywords are there. Okay. So these 32 words are called as keywords or reserved word. Every word you can see in the table, they have a specific meaning as per the C language. As per the C language, every word is having a special meaning. They are used according to that purpose, that meaning. Okay. So you should not use them as you wish. When you are using that word, it has that meaning only as per the language. Got it? So, and remember one thing, you no need to mug up these 32 words. You don't need no need to remember them. When you come across a concept, so where we use these words, so you will simply, you can know by looking at that, you can say, okay, this is a keyword, I should not use it as a normal word. Every word, auto, break, case, care, constant, const is constant, continue, default, do, double, else, enum, extern, every word is having a special meaning. When you come across that any concept, there you will see. When you start writing data types, you will see integer, float, char, double, long. When you come across with writing if else, so you will say if else are there. When you start come across with loops, you'll have while, do, for, break, continue, switch, case. All these are the keywords. When you come across the concept, you will understand the meaning of that. Okay. So you just remember there are 32 such kind of words are there, and don't try to remember every word like auto, break, case, care. You no need to remember them like that. You look at the word, you can identify, okay, this is keyword, but not now when you come across them. Okay. So that is about identifiers. And next, So this is one of the beautiful concept in it started from C language, data types. Okay, so you can have data of different types. You can have data of different types. So those data for that different types of data here in C language, every type of data is divided like this. A type defines a set of values and a set of operations that you can apply. So data means you can say name. So what you write in name? You will write alphabets. When you say roll number, you'll write number like 45, 46, 47. When you are considering the marks of a student or that CGPA, you'll have like 7.5, 7.6. See, when we are discussing these three types of data, the values or the that is taking is different from each other. For roll number, it is one type of data. For CGPA marks, it is one type of data. For name, it is one type of data. For grade, it is one type of data. Because when you say grade, you say A grade or B grade. When I say name, it is something, a collection of alphabets, group of alphabets. So you have different types of data are there. Right. So this different types of data, it got basically divided into two categories: primary data type and derived data type. Primary and derived data type. So primary data type, it includes integer, float, and character. Integer, float, and character. So that are included in primary data type. Derived. This primary, it can also be called as basic data types, fundamental data types. Okay, you can all these are the different names. Okay, what are the different names as? Basic data types, fundamental data types, primary data types. Derived data types. So these derived data types are, they will come from this primary data. They'll come from the primary data. With with the help of this primary data, I'll be getting these derived data types like arrays, pointers, structures, unions. All these are the derived data types which without this primary you cannot write these derived types. Okay, so we'll look at the look into the concept of primary data types now. We'll look at the derived data types later, because everything in arrays, pointers, structures, unions, everything is one concept. Like if I should say according to your college syllabus or something, every derived data type like arrays, pointers, everything is one type, one unit. Okay, so with this derived data types, you can it is having very big concept. Okay, everything is like one unit here. Okay, one a different chapter. But as of now, we'll discuss primary data types now: integer, float, character. So what is integer, what float, and what char? So we'll look at them in detail. See, an integer type is a number without fractional part. without fractional part. That means 2, 3, 4. Like very simple, all the whole numbers minus infinity to plus infinity, including 0. Okay, so that is integer data. An integer type is a number without any fractional part. And C language supports 4 different sizes of integers. 4 different sizes of integers. So what are those 4 different sizes of integers is, I call it as short int, long int, long int. So how they are different from each other? So in the table you can look there and you can identify. So what is the difference? So what is the difference in? I have written 3 types. Out of in 4 types, I have written only 3 types. So with those 3 types, you can identify how they are different. See, short int, when you are storing that short int in your memory, it occupies 2 bytes of data. It occupies 2 bytes of data. So I already told you units of your memory: bits, bytes, kilobytes, megabytes, gigabytes, terabytes, and that it occupies just 2 bytes of your space. That means 16 bits. So 16 combinations of ones and zeros you can store. 16 positions are there, 16 different combinations you can use. So with different combinations of ones and zeros, so the maximum and minimum value you can store is this one. You can store, this is the range of short integer. That means in the negative you can store up to minus 32,768 till positive 32,767. In between all these values you can store in short integer. In a short integer you can store a values of this range. Okay, if you have a number greater than this range, that is minus 32,769 or 32,768, so you cannot store those values in a short integer, because its range is only the minimum value you can store is 32,768 minus 32,768, and in the positive it is 32,767. Whereas coming to integer, an integer, normal integer, it can store, it occupies 4 bytes on your memory, and the number you can look there, it is something like 214 crores 74 lakhs 83,648. So this number, it can occupy 4 bytes. That means 32 bits it requires. It requires 32 bits for storing a integer, and the range is that number. And again you have long integer. A long integer, it occupies 8 bytes. Okay, look at the range of that number. It is something very big one. Long int, it occupies 16 bytes. 16 bytes. So I'm leaving it for your imagination. That such a big number, it can store that big number, which stores which occupies 16 bytes. Okay, so this is about integer data without a fractional part, without any fractional part. That kind of data I call it as integer. And these are the four types of integers, right? And other than these four types, we also have different two different things in integer, that is signed integer, unsigned integer. That is a signed integer and unsigned integer. So what is this signed integer and unsigned integer? So before that value or before that number, there is a sign representation is there, right? Minus plus. So four types of integer. So for four types you have signed short int, signed int, signed long int, signed long int. In the same way you have unsigned short int, unsigned long int, unsigned long int, unsigned long int. So that means with these two combinations, total you have eight types of integers are there. Eight types of integers. So what is the difference between the signed and unsigned? Signed means if you place a sign, these are the signed integers. That means you can place a negative value and as well as you can place a positive value. You can place a negative and positive values. But whereas in the unsigned integer, you don't specify any sign. You don't specify any sign. So it will have only the positive values, because when you are not placing any sign, by default it is a positive value. So when it is a positive value, the range of your shorthand, it becomes 0 to, because there are no negative numbers. When there are no negative numbers, there are only positive numbers. It ranges from 65,530, only all positive numbers. This is for unsigned short integer. This is for unsigned short integer. Simple. So there are negative numbers, 32,768 negative numbers are also there. So those positions can also be used for storing a positive number. So the range of the positive number increases to its double. And that 65,000, that is simply the combination of positive and negative numbers. So all the positions are kept only for storing the positive numbers in the case of unsigned. So there is no scope of negative numbers in unsigned. Whereas in the sign, so when you place a sign, so you can place a positive sign or you can place a negative sign. And remember, so where to place the positive and negative signs? So I told you, for short integer it requires 2 bytes. So 2 byte means in total it will take 16 bits. It takes 16 bits. So like this, you have 16 bits. Out of these 16 bits, the first bit is always reserved for placing the sign. First bit is always reserved for sign. So in the bit, you can place only 1 or 0, right? 1 indicate that it is a positive number, and 0 indicate that it is a negative number. In unsigned in a signed category, the first bit is always reserved for storing the sign. And that means the number you are storing is a positive number or a negative number. If the first bit is occupied by 1, it is a positive number. If the first bit is occupied by 0, it is a negative number. Got it? So
Yes.
this is about integers. So total you have 8 types of integers. So by defaultly, when I write
I still
simply,
didn't understand.
Amma, what?
Sir, I still didn't don't understand signed. What's the meaning of signed?
What you didn't understand?
Signed.
Signed.
Yes,
So
sir.
signed means you will have a sign, a positive or negative sign you will place. So by defaultly, what is there in the table? So they are signed range because it includes a positive number range and negative number range. When it is unsigned, the minimum value is 0 and the maximum value is 65,000. So there is no scope of a negative number in unsigned. Okay. When it comes to the sign, you have to place, you have to reserve the first bit. The first bit is reserved always for storing the sign, whether the number is a positive number or a negative number. So if the first bit is filled with 1, that number is a positive number. If the first bit is filled with 0, that number is a negative number. You will have signed short int, signed int, signed long int, signed long int. So got it?
Yes, sir, I got it.
Yeah. And next, coming to float. So float is a data which includes a decimal value. In integers, you don't have a decimal value, you say either 2 or 3. But in the float, you will have the decimal part also. In the float, you will have the decimal part as well. It is used to store the decimal numbers. That means the numbers with decimal point, and after that, you will have some value. Okay. So we have 3 different types of float values. We'll have 3 different types of float values. What is the different types is a float, double, long double. Float, double, and long double. So I have shown you the storage size. Float occupies 4 bytes, double occupies 8 bytes, long double occupies 10 bytes. So what is the difference between float, double, and long double? So we have different ranges like 1.2 e power minus 38. So other than that, I'll tell you simple. When it is a floating value, we will call them as floating point numbers. Float, we simply call them as floating values or floating point values. Okay. When it is a float data, after decimal point, you can get 6 digits after decimal point. When you apply float, after decimal point, you can get up to 6 digits. Double. In double, uh, you can get up to 16 digits. After decimal point, you can get up to 16 digits. Okay. Long double. If you want more than 16 digits after decimal, you go for long double. Okay. So the difference in this data, the variance and float, is the number of digits you require after the decimal point. That means if you want more accurate, you go for double. If you still want more accurate, go for long double. After decimal point, you'll get 6 digits in float, 16 digits, sorry, not 16, 16 or 14 digits, I guess. I guess it is 14. But 6 digits in float, 14 or 16 digits after the decimal point in double, and more than that in long double. Okay. And next is character data. So this is the most basic data type in C language. If you want to store any single character, anything in a single quotations, single quotes, that is a character, but only a single one. If I say A, that is a character. A, character. This is a character. And even you can place your digits. This is also a character. A digit placed in single quotations is also not an integer. It is not treated as a number. It is also considered as a character. And this character data, it occupies 1 byte. It is also this is also having signed and unsigned. Generally, we use unsigned character, so which ranges from 0 to 255. Sir, you are saying something like a at the rate 8, and how it ranges from 0 to 255. These characters will store, they'll not store directly. For all these characters you have, so these will be converted into some standard representation. These things get converted into a standard representation. So that standard representation is called as ASCII. That standard representation is called as ASCII. So what is this ASCII means? American Standard Code for Information Interchange. American Standard Code for Information Interchange. So we use this ASCII for converting every character. So whatever you can see on your keyboard, almost all the symbols, all the characters, lowercase, uppercase, special characters. So almost every alphabet, every special character you see in the keyboard, it is associated with some numbers. So those numbers are assigned by this American Standard Code for Information Interchange. So you can see the number of columns here. The first representation is decimal representation, hexadecimal, octal, and character. Okay, so you no need to remember all these things. You can remember. So what is the starting point for A? So A is in decimal format. A is represented with 65. That is capital A. Okay. Small a is represented with 97, and digits is represented starts with 48. So if you know the value of A, you can calculate the value of E. Right. So you don't need to remember them. You just try to remember the starting point. That is the first position of lowercase alphabets, uppercase alphabets, digits. Digit as a character. If I represent 0 in single quotations, that is having an ASCII value 48. Okay, got it? So we'll store this every character. You take whatever character you say, you'll have it is associated with some number. Okay, hexadecimal, octal, that is the different representations. So 48 is represented as 30 in hexadecimal. 48 is represented as 60 in octal. Okay, so don't worry about that.
Sir,
See, hello.
hello, sir.
Yes.
Sir, when do we need this AICCII code, sir?
For storing the, we don't need actually, but the computer, when it is trying to store the data that you give as a character, that is stored in terms of these ASCII values. In the program, in the C program, if I use any alphabet, any character, so that character will be stored, it is converted with an ASCII value, and that ASCII representation will be stored in your memory. So we don't need to give, you can simply write A. It will find out its respective ASCII value, and that 65, that is converted into binary, and that will be stored.
So, sir, while writing with C program, should we write this DEC number or should I write this character?
No, we can simply write characters.
Okay, sir.
We no need to write. But in few cases, when you want to when you are doing some kind of comparisons, so there you require this ASCII value. So that is why I'm telling you to remember the starting point of uppercase alphabets, starting point of lowercase, starting point of digits. So you just need to remember those things. Someone, they don't ask you to what is an ASCII value for percentile. Okay, but you should know what is where the uh, alphabet start and where the digits start. Okay.
Okay, sir. Thank you.
So this is about characters and ASCII values. And next is variables. So this is a very important thing in C language, variables. So yesterday when we are discussing about memory, so your RAMs, the programs it directly when it want to store a data, it will store in your RAM. So your RAM sizes it ranges like a minimum of, nowadays the RAM sizes are a minimum of 8 GB or 16 GB like that, right? 16 GB means 16 into 1024 cube, because kilobytes, megabytes, gigabytes. So 16 into 1024 cube, this many number of bytes. That means your RAM size is this much. These many number of bytes, that 1024 cube now. These many number of bytes are there in your memory. Okay. And suppose if I want to store an integer value, suppose I want to store an integer value. So what I'll do is, integer it occupies, how many bytes an integer occupies? A normal integer occupies 4 bytes. That means out of these many number of bytes, it will allocate, like every byte is having some number. The byte address, it starts with 0, 1, 2, 3 till the last number -1. If this total value results to n, 0 to n-1 number are the bytes. So out of these many number of bytes, for storing a number you are using 4 bytes. So these 4 bytes are used for storing an integer value. So with the help of these variables, I am trying to give some name to that memory location. I am trying to give some name to that memory location, because whenever I want to get the value, I can access that value with the help of that name which I give. Okay, suppose if I give it the name of this is A, and whenever I want to access that value, I can simply use it with the help of that name. That name A is called as a variable name. Variables are the named memory locations that have a type. Here, if I simply say A, there I have to specify what type of data I can store there. I can store integer data, because integer data it occupies 4 bytes. As earlier I told, for integer I have taken those 4 bytes. If you want to store a float value, it, suppose let us assume float is, it also occupies 4 bytes. At some other location 4 bytes are there. So those 4 bytes are simply represented with the name p, and in these 4 bytes I can store only float data. In A is for integer data, B is for float data. So whenever you want to give any name to the memory locations, first of all we call it as a variable declaration. Each variable in your program, it must be declared first. First of all I have to declare it. So we'll see that. So when a variable is created, the declaration gives a symbolic name, and then definition reserves memory for them. That means you are giving some name. In a memory you want to occupy, you want to reserve some space. So that some space will be given some name, and that some space is reserved for that variable. That can be done with the help of variable declaration. That can be done with the help of variable declaration. So we'll come across something called as syntax. Something called as syntax. What is this syntax? Is syntax is simply when you are using any language, in that language you have to follow some rules and regulations. Any language, in the programming language, those rules and regulations are called as syntax. In any programming language, so every programming language is having their own rules and regulations. That means when you want to use a variable, you have to follow some rules. So for every concept, we'll discuss the syntax of that for every concept. Okay, so that rules and regulations are called as syntaxes. So first of all, when you want to use the variables in C language, you should know what is the syntax for writing it. Then only you have to use it. Without knowing the syntax, you cannot use it in the program. So the syntax for writing the variable or declaring the variable is, first of all, you have to specify the variable type. So what type of variable you are storing? You want a variable of type integer, float, double, long int, short int, character. So what type of variable you want? That is a variable type. And next one is variable name. Next one is variable name. What name you want to give to that variable? Whether you want to name it as A, whether you want to name it as B, you want to name it as student roll number, you want to name it as length, you want to name it as height. What name you want to give? Here, variable name, the name you give, it should follow the rules of identifiers. The name you give, it should follow the rules of the identifier. Okay, so this below you can see the example. The variable type is integer here, and the variable name is length. In the second example, variable type is float, variable name is height. Got it? So this is about variables. So for taking our inputs, for displaying the result, that is for output. So we'll use many variables in every program. We'll come across with these variables. The very first step we write in the program is this variable declaration only. That is the very first step in writing the program. You will use it for number of times. Simply, when you write this statement, that is int length. What happens here? You want to give a name as length, which is of type integer. So it verifies how much amount of space it requires for integer. It requires 4 bytes. In the entire memory, it will go and verify where the continuous 4 bytes are available. Okay, if these 4 continuous bytes are freely available, then the compiler, what it will do is, it will reserve these 4 bytes, and these 4 bytes are given with a name, which is length. These 4 bytes are given with the name length. This is what happens. This is a logical name, symbolic name that is given to your memory location. In the length, if you are storing some number, in the same number, if you want to use in the future, you can use that value with the help of this name called length. So, okay, that is about variables. So with this, I'll stop for today's session. If you have any doubts, so you can just clarify now. So have any doubts?
No doubts? If no doubts, we will stop.
No, sir. No,
Say
sir.
is
Thank you.
variable is a primary data.